Hi guys, this will be dealing with geometric progression. Now, when a sequence has a constant ratio, for example, now we are dealing with ratio in this place. For example, when we have a sample, imagine we have 1, 2, 4, 8, 16, and so on. So the ratio in this sense is 2 divided by 1, and that's 2. We have 4 divided by 2 is also 2. We have 8 divided by 4, which is also 2. Even 16 divided by 8 is what? Is 2. Another example like that is when we have AR, when we have AR square, then when we have AR 3. So when we do this now, AR divided by A. So A will cancel A, we will have R. Also, we can have AR square divided by AR. So this one will cancel this. So one after this will cancel this and we remain what? 1R. So this is a constant ratio and also a GP. So the n terms of a GP is ARn minus 1. This is the formula for the n term of a GP. Then we have sum of a GP, sum of GP. So we have sum of GP, that is, we have A into bracket Rn then minus 1, so all over R minus 1. And this one can be used when our ratio is greater than 1, if R is greater than 1. So we have another one, or we can have A into bracket of 1 minus R n then divided by 1 minus R. So this one can be used when 1 is greater than R, or yes, when 1 is greater than R. So this one can be used. And we have sum of infinity, sum of infinity, that is, we have S infinity, which is equal to A all over 1 minus R. We'll be dealing with some examples now so that we are going to get all. So in this place, so if R less than 1, if R less than 1, so if R less than 1, we are going to use this, and this if R is greater than 1. Thank you. So this is an example. Determine the 10 terms of the series 3, 6, 12, 24. They said the 10, and I said the n terms of the GP is ARn minus 1. Now our A is what? Our A is first term, which is 3. Our R is, we can do T2 divided by T1, which is equal to 6 all over 3, and that's what? That's 2 actually. If you do 12 divided by 6, it's also 2. So we are having T10 is equal to ARn minus 1, which is equal to our A is 3, then multiplied by 2, and our n is 10 minus 1. So we are having 3 multiplied by 2 raised to the power of 9, and that's equal to 3 multiplied 2 raised to the power of 9 is 512, and we are having 1536. This is our T. That's very simple. Just input your formula. So this is another question. Find the sum of the first 7 terms of this series 1 over 2, this and this. First of all, convert this to fraction. We have 1 over 2. This one will be 3 over 2. 2 multiplied by 1, 2, then plus 1, 3 over 2. So 2 times 4, 8, then plus 1, 9, all over 2. And this one, 2 times 13, that's 26, then plus 1, we have 27 all over 2. Now they said the sum, and the sum, we have two formula, but first of all we must have our R. But we have our A to be 1 over 2, but to find our R, we said 3 all over 2 divided by 1 all over 2. We said T2 divided by T1 the other time. This is the division. Now this one can be changed to multiplication. This implies 3 over 2 multiplied by 2 all over 1. This will cancel this, and our R is going to what? 3. Now our R is 3 and it's greater than 1. So R is greater than 1. R is greater than 1. So we are going to use the formula for r greater than 1, which is Sn is equal to a into bracket into bracket Rn minus 1, then r minus 1. So just input the formula, the value. A is 1 over 2 into bracket. What is our r? 3. There is 7. 3 raised to the power of 7. Then minus 1. Then we have our r to be 3 minus 1. So this will imply we have 1 all over 2 into bracket. When you do 3 raised to the power of 7, we are going to have 2187, then minus 1 all over what? All over to 3 minus 1. Now, from this place, your Sn is going to be 1 all over 2 into bracket 2186. So when you do this, you are going to have Sn to be equals to 1093 divided by 2, which you are going to have your Sn to be 5461 all over 2. How do I go about this? 2187 minus 1. So when you do it, so you have this now. When you do this, it will be 218786. So and this is just this and this divided by this will give you this. Now this is another question. The second term of a GP is 4. Why the fourth term is 16? Find the sum of the first 5 times. But before we find the first sum of the first time, we have to have our r and we are going to have our a actually. So this is how you are going to solve it. Second term. And second term here is going to be a r. You know our first term is a and the common difference is r. So the first term plus the difference common ratio will be your second term, and they said is 4. So we have our fourth term, which is a r raised to the power of 3, and they said is 16. So this is equation 1, this is equation 2. But this one you cannot do it in simultaneous equation. You are going to use indices to do it. So divide equation 1 by equation 2. So you are going to have a raised to the power of 3 divided by ar, which is equal to 16 all over what? All over 4. Now cancel this one here. We are going to have r2 divided by what? Divided by 4. Now this can replace r is equal to square root of 4. Square both sides actually. So r is equal to square root of 4. If you square this place and also this place, so this one will cancel this. So r is going to be 2. So if r is going to be 2, in order for us to get our a, input r in equation 1. So we have ar is equal to 4. Where we know our r now, we know a2 is equal to 4, and the same thing like saying 2a is equal to 4. So now divided by 2 divided by 2, a is equal to also what? Is equal to 2. And now we are going to find the sum of the first 5 actually, first 5. Then now our r is what? Greater than 2. We are going to use that formula, which is greater than the formula that is greater than 2 actually. Sn is equal to a into bracket r n minus 1 divided by r minus 1. So we have s5 is equal to our a is 2 into bracket 2 raised to the power of 5 minus 1. Then we have 2 minus 1. And when you do this actually, 2 into bracket 32, 2 raised to the power of 5 is 32 minus 1. Then this one is 1. So we are having 2 into bracket what? 31. And this is going to give us what? 62 actually. This is giving us 62. So that's how you are going to find it when you are asked to find something like this. Now this is another example. I think this should be final example. What type of question they can ask you? If they ask you for the common ratio, the first term, the sum, and the n terms, or the sum to infinity. Now find the sum to infinity of this series, this, and this. Now sum to infinity, as infinity, I said a divided by 1 minus r. We have a to be 1 over 4. Then our R, we are going to look for our R. And when we are looking for R in GP, we are going to say 1 over 8 divided by 1 over 4. And this implies 1 over 8 multiplied by 4 over 1, which our R is equal to 1 all over what? All over 2. So you can bring this one down to the formula. S sum to infinity is equal to 1 over 4 divided by 1 minus 1 all over 2. Now when you do 1 minus 1 over 2, when you find this s here, we have 2 here, 2 here in 1 is 2, and to multiply this is 2 into 1 multiplied by 1, so we are having 1 over 2 in this place. So we are having, this is not going to give you 1 all over 4 divided by this division 1 all over 2. Now this can implies 1 over 4 divided by 1 all over 2, where we are going to have 1 over 4 multiplied by 2 all over 1, and this will give us 1 all over 2. Now it's very simple to deal with. When you continue practicing this, it will be very simple for you to do it. Thanks for always watching our videos. Don't forget to subscribe if you have not. Thank you.